Hi everyone, this is a screencast on double replacement reactions. This is the second of the two screencasts on double replacement reactions. The first screencast is on solubility rules and how to use the solubility rules to determine whether or not an ionic compound is soluble. In this screencast, you're going to learn how to predict the products of a double replacement reaction, and you'll learn how to determine whether or not the reaction will occur. So when the following solutions are mixed, the following observations are made. When we mix lead 2 nitrate and potassium iodide, okay, or when we mix cobalt 2 nitrate and potassium iodide, we will make these observations. So when we mix lead 2 nitrate and potassium iodide, we get a yellow solid that forms. When we mix cobalt 2 nitrate with potassium iodine, nothing happens. No reaction occurs. Nothing forms. Okay, no new substances form. So the question is, why does one reaction occur and not the other? So why do we see this yellow precipitate? Remember, a solid that forms is called a precipitate. Okay. Why do we see this yellow precipitate form? Why does a reaction occur in this scenario and not in this scenario? Okay. And what are the products of the reaction? So after this screencast, you will be able to answer those questions. So in order to determine the products of a double replacement reaction, we can use a general form. So the double replacement reactions always follow the same general form. Okay, what is happening in a double replacement reaction is you have two ionic compounds, right, that swap cations and anions. Okay, so for example, in my first reaction here, I have a cation, which I'm going to call A. So my potassium ions, I'm going to call A, all right, are bonded with my chloride ions, which I'm going to call B, all right? And I'm reacting that with silver nitrate. My silver ions, so the cations of the second compound I'm going to call C, are bonded with nitrate, all right, anions that I'm going to call D, all right? So I have AB plus CD, all right? And what happens is the cations swap places. It's like dance partners, switching partners on the dance floor, okay? So my potassium and my silver, those are the cations. They're going to swap places with the anions, okay? So my potassium, all right, will go with my nitrate, and my silver will go with my chloride, okay? So my potassium is A. Whoops. Uh-oh. All right, let's get that back up there. So we have AB plus CD. Okay, so my potassium is A, all right, my nitrate is D, so I get AD, all right, plus, and my silver is C, all right, and my chloride is B, all right, so I got AB plus CD yields AD plus CB, all right, and if you go ahead and pause this screencast, all right, and label these up here, you'll notice that they also follow the same form. So the general form of the reaction is AB plus CD yields AD plus CB. So how will we be able to tell whether or not that reaction will occur? It's going to be determined by the products. Okay, so you need a certain product to form in order to drive that reaction. All right, what type of product will drive the reaction to occur? It will be one of these that are listed here. So if one of the predicted products is an insoluble product, then yes, the reaction will occur. okay, you will know whether or not those ionic compounds that are the predicted products are soluble based on the solubility rules that you learned how to use in the previous screencast. So you always want to have your solubility rules handy, okay? All right, so if you get an insoluble product, then yes, the product will, or the reaction will occur. If you get water as a product, water, that would be a new substance forming. And so, yes, if water is formed, then yes, the reaction will occur. But the last one takes a little bit more focus. You need to memorize these, okay? So if a gas forms, and you do need to know these here, all right, then yes, a reaction will occur. If I get hydrogen sulfide gas, H2S, all right, so if you see this as one of the predicted products, all right, then yes, the reaction will occur. If one of your predicted products is H2CO3, then you actually need to write that as CO2 gas plus H2O. Because what happens is the H2CO3 is not stable. It is not going to exist this way. It is going to decompose into carbon dioxide gas and water. Okay, so notice if I pull out 2 hydrogens and 1 oxygen to make water here, what I'm left with is CO2. All right, and that's what happens. All right, so you need to recognize that H2CO3 is going to decompose into CO2 gas plus H2O, all right, plus water. H2SO3, you need to know that that decomposes into sulfur dioxide gas and water, all right? And ammonium hydroxide will decompose into ammonia gas and water, okay? So like I said, the memorizing these usually takes a little bit more focus, so make yourself some flashcards, do what you need to do, all right? Usually folks can remember the first 2 pretty easily, all right? And it's this one that takes a little bit more time. All right, so these are the steps that you're going to use to determine what the products of your double replacement reaction are and determine whether or not the reaction actually will occur. So first, you're going to use the general form of the reaction to determine which ions will come together to form the new ionic compounds. You're going to determine the charges of the ions and use these to write the formulas for the products. So changing the subscripts so that the charges cancel. And then you'll determine if the reaction will occur based on the types of products formed. So using the list on the previous slide. All right, so for example, if I have lead 2 nitrate plus potassium iodide, right? What I am going to get, all right, is, look, I'm going to have my lead 2 ions, all right, and my nitrate ions, right, and my potassium ions and my iodide ions, all right, in solution, all right, and my cations are going to swap places, all right. So let's look at my ions that I actually have here. Okay, so this is going to be, this is lead 2, right? So this is Pb 2 plus, all right? And then I have nitrate ions here. Nitrate ions are NO3 minus, right? These are potassium ions, right? And these are iodide ions. So you want to look at their charges, okay, to see how they are going to form new products. All right, so my general form, all right, was AB plus CD, all right, is going to give us BD oh, whoops, not BD. It's going to give us AD plus CB, okay? So my lead 2 has a charge of 2 plus, all right, and it is going to go with my iodide, all right, which has a charge of 1 minus. All right, so that's going to give me PbI2, all right, because I have a charge of 2 plus for the lead and a charge of 1 minus. For the iodide, I need 2 iodides for every 1 lead in my formula, okay? Then my other product, okay, is going to be my potassium ions bonding with my nitrate ions. Well, both my potassium and my nitrate are both, my potassium has a charge of +1, my nitrate has a charge of 1 minus. Okay, so that is just going to give me KNO3, both, all right. One of each in order to get a neutral compound, or in order to have an overall charge of 0, okay? All right. In order to balance this, okay, look, I have 2 iodides here, all right, 1 on the left, so I'm going to have to add a 2 there, okay, and then that then changes my potassium to be 2 on the left, so I'm going to end up with a 2 over here, okay, and then my nitrate will be balanced, okay. For our states of matter, we are going to use our solubility rules to determine, okay, of course, my 2 reactants have to be aqueous, all right, so that the ions are free to flow and able to react. We're going to use our solubility rules to determine if either of these 2 products is a solid, okay? Remember, if it is soluble, then it will be aqueous. If it is insoluble, then it will be a solid, okay? So we're going to look at our solubility rules here, okay? And, all right, when we look at our solubility rules, all right, for PbI2 and KNO3, all right, so we have to check out PbI2 and KNO3, all right. So for lead 2 iodide, all right, there's an iodide ion here, all right. So iodide compounds are soluble, all right, except if they're bonded to lead 2, all right. If they're bonded to lead 2, then they are insoluble, okay. So that means that lead 2 iodide is insoluble. So yes, this is a product that will drive the reaction to occur. This is going to be solid, all right? For KNO3, all right, I have a group 1 metal. Potassium is a group 1 metal, all right? Group 1 metals are soluble and there are no exceptions. So KNO3 is going to be aqueous, all right? All right, so my lead 2 iodide, all right, it's insoluble, all right, and so this is the product that drives the reaction to occur, okay? So we have lead 2 nitrate, aqueous, plus 2 Ki, aqueous, yields PbI2, solid, right, plus 2 KNO3, aqueous, right? All right, when we look at our cobalt 2 nitrate, all right, plus potassium iodide, all right, when we go ahead and predict the products, why don't you go ahead, pause this screencast and see if you can predict the products using the general form of the reaction. All right, so when we predict our products here, you should get, okay, cobalt to iodide, all right, so it'd be COI2, all right, because cobalt has a charge of 2 plus, all right, and iodide has a charge of 1 minus, so when they go together, I'm going to need 2 iodides for every cobalt. All right, and then I'm going to get potassium nitrate, KNO3. All right, potassium has a charge of +1, nitrate has a charge of -1, so they'll be in a 1-to-1 ratio in that compound to make a neutral compound. Okay, when I go back to balance this here, all right, I have 2 iodides on the right, so I'm going to add a 2 right here to balance that. Then I'll have 2 potassiums on the left, so I'm going to add a 2 right here to balance my potassiums, and then my nitrates will be balanced. Okay. Of course, your 2 ionic compounds always have to be aqueous on the left, all right? You have to dissolve both of the ionic compounds in water in order to even try to make a double replacement reaction occur. All right, so they are aqueous, all right? And then we're going to use our solubility rules to determine the products of these two. So we have cobalt 2 iodide and potassium nitrate. Okay, cobalt 2 iodide and potassium nitrate. So we have cobalt 2 iodide and potassium nitrate. These are the ones we need to check out here. So iodide, all right, is right here. All right, it is soluble unless or except when it is bonded with silver or lead 2. All right, in cobalt 2 iodide, the iodide is not bonded with silver or lead 2, and so this compound is soluble. All right, so it will be dissolved in the water. Okay, the potassium nitrate, potassium is a group 1 metal. All right, so it is soluble. There are no exceptions. So both of these compounds are both soluble. Okay, so since both of the products are soluble, right, and we also did not get water and we did not get a gas, no reaction occurs. All right, so this is no reaction. All right. Okay, here is another example. So I want you to go ahead and pause the screencast. All right. Try to predict the products. All right. Use the general form of the equation. Use the charges of the ions that are bonding together to determine what the subscripts are. Right. And then go back, balance the equation. All right. When you have your products, all right, then you want to use your products to determine whether or not the reaction occurred. So you're going to look to see if there is an insoluble product. You're going to look to see if there's water, or you're going to look to see if there were one of the gases that you need to know. All right. Okay. All right, so here's our list here, all right, that you're going to look for. All right, you're going to look at your products and you're going to compare them, all right, to this list to see if they are in the list. All right, so when you go ahead and predict those products, all right, you get H2O, all right, and you get calcium nitrate. Okay, H2O is water, right? And when water forms, then yes, a reaction occurred. This is our new substance that formed in the reaction. Okay, for calcium nitrate, you can look at your solubility rules. Okay, and looking at your solubility rules for calcium nitrate. Nitrate ions are soluble and there are no exceptions. So calcium nitrate is soluble. All right. And so that is how you can know for sure that the calcium nitrate is aqueous. All right. So this is the final balanced equation that you should get. So here's another practice. So again, go ahead, pause the screencast. Use the general form of the reaction to determine the products. All right. Use the charges of the ions that are coming together to figure out what the subscripts are going to be. All right. Balance the equation and determine whether or not there is a product that will drive the reaction to occur. Okay, so again, here is our list that you should be looking at or trying to remember when you are looking to see whether or not the reaction will occur. Okay, so you should end up with calcium chloride plus, All right, and remember this one. All right, H2CO3. Remember what happens with H2CO3. H2CO3 decomposes into H2O and CO2 gas. All right, so no reaction occurs. So a reaction does occur. All right, so for our balanced equation here, for our final balanced equation, you are not going to write H2CO3. You're going to write that as H2O, liquid, plus CO2, gas. So we have CaCO3 aqueous. All right, and when we balance this, it's plus 2 HCl aqueous. All right, yields CaCl2 aqueous plus H2O liquid plus CO2 gas. So these are the products here that are driving the reaction to occur.